Hello everyone, welcome back to Everything Anything Computing. This is lesson 5 of our Learn Android Development with Kotlin series. In the last lesson, we opened IntelliJ IDEA and wrote our first Kotlin program, Hello World. If you haven't watched that one yet, I suggest checking it out first before continuing here. Today we're going a little bit deeper. We'll learn how to store information using variables and how Kotlin understands different types of data. So first things first, I usually like to emphasize to my students that everything in programming is about how you're going to store your data, how you're going to reference the data, and how you're going to manipulate the data, and how you want to output this data. So basically, because everything is about data, we need to know how to write our Kotlin language in a way that our computer will understand that whatever it is that we want to do is store some data in it. So how to do this, first of all, is we start with the building blocks of Kotlin programming language in data storage, which is basically variables. So what are variables? These variables are what allows us to store the data that we're talking about. You can imagine it as a label. If you have a box and you have a label, and you want that label to reference what is inside the box, that label is what we call a variable. So basically what it does is you want to tell your computer that give me a memory allocation. That memory allocation, I want to give it a label. And that label, every time I want to check what is inside the memory allocation, I'll just use my label. So that label is what a variable is. And in Kotlin, there are two ways of writing a variable, or rather, there's two ways of calling a memory allocation. The first way is using a keyword called val, and the second way is using a keyword called var. So basically, when you write, like I mentioned, Kotlin is a language. A language communicates. So if it is communicating, it has different keywords within it. So your compiler just checks in for those keywords. So in this case, in variables, when you're trying to declare variables, there are only two types of keywords, var and val. So your compiler, anytime it sees val, it knows that whatever is within my box or my memory cannot be changed. The moment it was assigned a value, that value should remain permanent throughout my programming or throughout my application running. And then var means that later on, maybe I can assign a different value in that memory or that box. So right now, store this value. But later on, maybe I can actually change it depending on the logic of your application. Let's go back to rent management. Or rather, when we started this course, I mentioned that we should find the best way. I usually like delivering content or teaching is I like finding a problem, and then using that problem, I want to use that problem throughout my teaching, especially now here in Kotlin, to explain different concepts. So now I want to go back to a problem that we had picked, which is we are trying to solve the problem of rental management, or rather landlord management. And in landlord management and rental management, basically, we need to store different data in it. Yeah? So I'm going to use two types of variables that are going to help you understand when do you use val and when do you use var in this case. So in the rental management, maybe you want to store the value of a tenant and how much they paid or what balance they have. So if you have this tenant and there's a tenant name, yeah, and you want to store the value of a tenant name, you want to tell your compiler, give me a memory, and inside that memory, this is the label of that memory, and inside it, I want it to have a name. So when referencing variable tenant name equals to Amina, Amina is the value of the name that is inside the memory that will never change. But if it is rent balance, you can imagine sometimes balance may change. Maybe the allocated amount of money that a user should pay is 20,000. But right now, the user only paid 10,000, or rather, the tenant only paid 10,000. So there's a balance of 10,000 that wasn't there. Sometimes they can pay 5,000 and then the balance may change, and so on and so forth. So the balance can always change. So now let me just do this practically so that you see what I mean. So we said there are two ways of declaring variables. So you say a val or var. So let's start with val. Val is the one we say that does not change. So in this case, we are referring to tenant name. Val tenant name equals to, and then here we write the name that we want, Amina. So basically what this code means is we have a declaration or a keyword val. That keyword has a label called tenant name. So every time I want to access this value, this is the value and it was assigned this value. So every time I want to access this value, which is Amina, all I need to refer is this tenant name. Yeah, every time I want to access this, I refer to tenant name. However, another thing that I need to remember is when I use the keyword val, so here in this case I have tenant name equals to, and I try to reassign it to Janet, you'll realize that we're getting an error here. And in this case, as you can see, when you click on it, it says change it to var, meaning val cannot change. So the minute I declared it as a val, I told my compiler that my memory will always remain the same. I cannot change the value inside my memory. So right here, this cannot work. So for me to make it work, I would need to change it to either var for it to actually work. So we can remove that. Now let's go to var. So var is the other keyword. This keyword allows you now to change the different values within your memory allocation. So in this case, we have rent balance equals to, let's say, 4,000. Yeah. So here, if I reassign this to rent balance equals to 8,000, or I could actually use an actual value, so that way 8,000, nothing changes. It means that I can always reassign this memory allocation anytime I want to make different changes, and so on and so forth. This can actually change to 400, 3,000, and so on and so forth, and nothing will change. So that's how you can think about it logically. So now let's go to something more interesting called the data types. So what is a data type? Clearly, you've seen here there are two different types of data. A data type in Kotlin is just you trying to tell your compiler that I have the data, it is stored in my memory, but it is either a text, it is a whole number, it is a decimal number, it is a Boolean value, either true or false, or it is a character. So that's the whole idea of data types. So variables have types, a type of data. Think of them as the kind of information we are storing. Here are the most common ones. We have the integers, the double, the Boolean, the string, and the char. So let's type them in IntelliJ and see how that works. So this now currently, when we are declaring it, normally Kotlin has something called the type inference. The type inference, when you initialize a value, depending on how you write it, it can infer and know exactly what you want to mean. So in this case, when you look at tenant is equals to Amina, because you're using the opening and closing quotes, it can tell that, okay, Amina is a string. But how do we actually do it to explicitly define different types? So in this case, we have a tenant Amina. So let's just create something new here. We have val, tenant age, int equals to 28. So now we've introduced something new, this int. So basically what it tells the compiler is that my memory allocation of reference tenant age is a type of integer and the actual value in that memory is 28. You can have another value, which is val electricity reading. It's a double and it's equal to 123.54. So this, you're telling your compiler that this is a value called electricity reading. It's of type double and the value itself is 123. So this is a variable of called electricity reading, type double, value of 123. Another one you can write is val is rent equals to false. So this is the Boolean value that returns either true or false. It's mostly used in conditionals when you try to compare. Has the rent been paid? If it has been paid, then return false. If it has been not paid, then return true, and so on and so forth. Another thing we have is val tenant initial, which is of char is equals to, so this is how you write it with a single quote, and then here we didn't write the type. The type is Boolean. Okay, and then finally we have a val tenant full name of type string equals to Janet Amina. Okay, so now we have all this with the different data types. We have a type of integer. So basically what it means is I have a variable, the label name is tenant initial, the type is a character, and the value is C, and so on and so forth. So another thing that I mentioned is the idea of Kotlin can actually guess the type of most variable, and it's called type inference. So what you can do, instead of actually explicitly saying that this is an integer, you can remove that and just write equal. And because this is a whole number, it automatically knows, okay, whatever my programmer is doing is he's referencing an integer. You can also remove this, and the compiler will know, okay, this is referencing a double because there's a decimal point. Now let's go to operators. What if we want to calculate things like rent balance? Kotlin has basic operators like add, subtract, multiply, divide, and remainder. Let's do this in a rent calculation. Do it practically so that you can know. So here, we can remove this. We have a variable called total rent that a user can pay equals to 10,000. And then we have a variable called what is the amount that was actually paid, which is equal to 4,000. And then finally we have a balance. And what that balance basically does is it takes the total rent, you can have the autocomplete, minus the amount paid. So you can have that. And then we can bring out the idea of print line. You remember when we were doing the hello world, we did something on print line and I explained what it is. So print line and write remaining rent balance is, and then we will learn about strings specifically. So this is something called string interpolation, where you are referencing the memory, and you're telling it, as I reference this memory, I want to actually get the value of the memory itself, which will be the total rent minus amount paid. So here we are referencing it using the dollar. You are breaking the sequence, because inside here it's basically, if you don't break that sequence, it will just print it as a whole string. So to break that sequence and say I'm referencing something outside, you use the dollar sign to reference a variable. Okay, so now when you run this, you see that here at the bottom, we have the remaining rent balance of 6,000. Okay, so let's go on. Now, let's try and do something to do with comparison. So when do we use Boolean values? We said Boolean values are values that return either true or false. So we can use this Boolean value when we are comparing certain things. So we compare them and then we say, if it is equal to something, then return something. So in this case, we have a val is fully paid. So we have a variable that holds a value of, is this rent fully paid? So if it is fully paid, it means that the amount paid should be equal to the total rent. So in this case, what it will check is, is this amount paid here? Is this amount paid equal to the total rent? If it is then equal to the total rent, then return true. But if it is not, it will return a false. So now when we print this, we print remaining rent balance is balance, and we can also print something else. We can print something else. So I just copy pasted that and write here has the tenant cleared rent? If yes, then return is fully paid. So now when we run again our application, you can see here it returned false. And this is because the amount paid is not equal to the total rent. So you can change this and try and see if it is equal, what it will return. So now the rent amount is 0 and it has returned true. So we can finally do a final practice. In this final practice, we can try typing this full example in IntelliJ and run it and see what it actually does. So now we can add something called the name of the tenant. So tenant name equals to Amina, yeah. And then the rent amount paid, total amount is 10,000. The amount paid, Amina this time paid 5,000 only. And then we can have the calculating the balance, which is the same way. And then we can have now the is fully paid. You can also change this. Instead of having it amount paid is equals to total rent, you can change it to balance is equals to 0. So meaning if the balance is 0, it means everything is fully paid. So now you can print the remaining rent balance, which is equals to balance. You can also add another print of a print line that says the tenant, just do tenant and then reference that tenant name. So that references the, actually I referenced it wrongly, so tenant name here. So that references this value. So when you print this, we're going to print this value, the value which is Amina. We're going to print the balance, this one, sorry. And we're also going to print if the tenant has fully paid his rent. So now, as you can see, we have this printout here. Okay, so what we've learned here is we can store information. And that information can be stored as either a permanent memory allocation, so the memory allocation cannot be changed, or can be stored as a mutable one, so the memory allocation can be changed. So you, and how to do that is either you use a keyword called a val or a var, and so on and so forth. So in this lesson, we learned how to declare variables, use different data types, and apply basic logic using operators. There's also another type of operators called logic operators that we haven't looked into, but when I'm introducing the next class, I will start with that before I get into the other things. So you're no longer just printing messages now. You're no longer doing hello world. Now you're working with real logic like app would. Next up, we'll learn about conditional statement using if, else, and when. So your app can make smart decisions. So that's what we're going to do next time. So the if, else, and when. And when we're doing that, it will be the best time to introduce the logical operators. If this was helpful, don't forget to like, comment, and subscribe for the next class on everything, anything computing. See you in lesson 6 and keep coding. Au revoir.